Hey guys, this is Logic Crazy and I'm Jonathan, and welcome to yet another advanced Java chess engine tutorial. In this tutorial we're going to be learning about random number generators and how to figure out if your generator is a good one or a bad one. Basically, if it is distributed properly or not. Now, if you recall from our previous tutorials, the random number generator is required for Zorbus keys, which are required for transposition tables, which help with our search method, whether it be alpha, beta, or as we're using the principal variation search. So the very core, or one of the core fundamental building blocks of a search engine is a truly random number generator. Now, obviously, you can't have a perfectly random number generator, but we can get really, really close. And there are a few things we're looking for. One is an even distribution, as I mentioned before, and basically that means no favoritism. We don't want the engine to favor even numbers or negative numbers or something like that. We want it just to be an equal probability of any number being selected. Because, for instance, if I told you to pick a number between 1 and 10, some of you would pick the same number. It would be a high probability that two people would pick the same number. And that is another example of a poor random number generator, because the probability is high that two random numbers might be the same. So in addition to our distribution, we also want to make sure we have a large range of numbers that we can pick from. So we want to pick numbers from positive billions to negative billions. And what we basically do is we pick random 64-bit numbers. So numbers that can be represented by 64 ones or zeros. And that gives us a really, really large range of numbers, and I find that it works really well. It's not necessary to go even bigger to like 128 bits, and going down to 32 bits ends up in a lot of problems because the numbers get too close to each other for comfort. So let's discuss how we're going to go about making this random number generator. What I've done is I've created two methods that create random numbers. Let's first look at this random bad number generator here. It would make a lot of sense, and it looks fairly straightforward. What we do is we create this math.random, which is a very common feature that we use in Java, and it's a common class, I should say, and it's obviously a double, so it'll be like 0.2490 whatever, that kind of thing. And so in order to make it a whole number, a positive number, we multiply it to get that decimal place out of the way. So we multiply it by just a massive number. And this number is so big that you have to add a little L. And it could be a lowercase or a capital, but a capital stands out a bit more. Makes it not look like a 1. So what we do is we multiply this number really big so that it turns into a whole number. And then we have to convert it into a long still. So it's going to just return this number, and that makes a lot of sense. And then what I've also created is what I think is a better random number generator. And what it does is it uses this thing called secure random. And obviously when you hear this word secure, you think, oh, you know, this is what banks use, this must be better. And that's kind of the idea they're going at. This is a better random number generator. So this is how you write it out. You do secure random, and then we give it a name. I just call it random, and make it a new secure random object. And then we return random.nextLong. And there are other options with this method here. We can do a next int and next boolean, double float, and so on. So it really gives you a whole range of options. But we are looking for that long, which is a 64-bit number. And I should make notes that this random number generator produces negative numbers. And one of the things we're going to find fault with this bottom random number generator here, this bad one, is that negatives are not included. It'll always come up with positive numbers. So that leftmost bit on that 64-bit number will always be a 0 in this method, which isn't good. So what I've done is I've created this method which I've called test distribution, and it will test how evenly those numbers are distributed, so that you can even try out your own methods and experiment and see if you can find something even better than the secure random number generator, which is very possible, and I encourage you guys to do that experiment, see what works best for you, and what's simplest, what's fastest, what's easiest, however you want to base it on. But what we're really looking for is quality here. So in our test distribution, what I've done is I've created an array of size, sample size. And this is a little bit like statistics here. We're going to get a probability of any number being generated and putting it in a specific sample size based on the population, which is really large. But if you haven't taken statistics, don't worry about that. This will be fairly simple. So what I've created was this integer called sample seconds, and it will just be the number of seconds that this test will run. So it'll be generating numbers for 10 seconds because this number is a 10 right now. And then it will print out the results. So we create a start time, and then we set the end time to the start time plus the number of seconds that we want it to run for. And when this while loop runs, we'll just make sure that the current time is less than or hasn't yet reached the time that we're supposed to end the loop. So that's how this little loop will go for a certain number of seconds. Then what we do is we create this array. And the array we make we allocate in the memory the size of the sample size. So 2,000 entries is what I've selected. You could have any other number, but that's sort of what I picked. As well, we have a little for loop in this while statement. So instead of every time we come up with a new number, making sure we haven't run out of time, I've just said run for 10,000 seconds or 10,000 loops, and then check, so that we're not constantly checking, because 10,000 loops will be really, really fast anyway, and it just saves us the time of checking all these all the time. So that's really what this for loop is for. And then afterwards, what we're going to do is go through each of the elements in the array and print them off. Now let me explain this crucial line here, which really is the big part of this method. So what this dist array is it's the distribution. So what we do is we have all these numbers from positive billions to negative billions, and we want to squish those down because there'll be a probability. Let's say it favors positive numbers or whatever it is, or favors big numbers, let's say. And we want to kind of squish it or condense it into an array of 2,000 in size so that this array has the same distribution, because we need to get it down to something manageable that we can see. Sort of like when you take statistics. You don't ask everyone in the entire world a certain question. You only ask a certain number of people, and you assume that the answers that they give you are going to roughly be the answers that everyone in the world would give you. So that's kind of what we're doing. We're going to condense the large amount of data into a small array. So here's how we do it. We do it with this line here. Oh, and one other thing I should mention, the way our distribution array will work is every time we get a certain number, let's say a 5, we might input on the 5th element in our array a 1 up. So it starts off as 0, then we add it to 1, then 2, then 3, so we see how many times did that number occur. And that's how our distribution array will work. It'll tell you how many times that number happened. And hopefully all the elements in the array will be close to the same. So here's how we do this. We take our random number generator, and then what we do is we squish it down into half the sample size, so into 1,000 entries. Now, the reason we're doing that is because this random number generator can produce positive and negatives. For instance, if I were to just switch this up here and do something like this. Now, if random number generator produces only positives, this would have worked. What we do is we take our random number and we modulus it with our sample size. So for instance, if our sample size happened to be 4, this number would only produce 0, 1, 2, or 3 as a result. But it would produce one of 4 different numbers. And so it's a way of taking a huge range of numbers and condensing it into something smaller. And hopefully you guys already know what modulus is from my previous tutorial, so I'm not going to explain it here. But what we do is, because we can have negatives, we have to actually take our random number and fit it in half the size of the array. So only 1,000 entry points, but actually our data is going from negative 1,000 to positive 1,000. So it's actually in a 2,000 number range. And so then what we do is we shift it over by half the sample size, so by 1,000 in this case, so that negative 1,000 becomes 0 and 1,000 becomes 2,000. And so therefore this random number, which could be positive and negatives, gets evenly distributed, or accurately distributed would be perhaps a better word, into our distribution array. So if you don't understand exactly how this works, don't worry, it still works whether you understand it or not. But just wanted to give you guys sort of an idea of how that is going to happen. Now I'd like to add one little side note. This distribution array, although it's going to try to accurately represent the larger population of the random generator, it will have one flaw, and that is the very center data entry. So the middle of the dist array, since it's at 2000 in size, the 1000th entry will end up being twice the count as everything else. And here's why. 0, when you do modulus, let's say 100, will end up equaling 0. Also, 100 modulus 100 is 0. So if you have random numbers from 0 to 100, 2 of those numbers will end up going in the same spot in our distribution array. So the very middle spot. So I just wanted to make that quick note of that, so that you are not going, oh, what's happening? There's always one spot that's way out of proportion to all the others. So now what we're going to do is run this. So we have our random number, and it should run for 10 seconds, give or take a few milliseconds here or there. And what's going to happen is then we're going to print off how many times each of those numbers happened, and hopefully it's somewhat even in the distribution. So I'll stop the program there. Now what we have here is a bunch of numbers. Just looking as they scroll through, I'm just selecting them all to copy them, is they all look like they're in the 15, 16, 1400s. Oh, and one other thing, the very top number will always be 0. And don't be alarmed about that either. So what I'm going to do is I'm just copying all of these numbers here, and then I'm going to open up Microsoft Excel. You could use any Excel program, but this is just a way to quickly visualize it, and it's not really necessary. I paste these in, and now each different row has a number from each line. And now what we do is we select this column, and we insert a graph to visually represent all those numbers. And here you can see, like I said, the very middle entry is twice the size, roughly, but they look fairly evenly distributed. Obviously, some numbers are a little bit taller than other numbers, and they're not all exact, but the longer you were to run this, it would be fairly even. And you can see, more or less, this is quite a very even probability. So we can say that this is a good random number generator. And if you want an even more accurate idea of this generator, run it for even more seconds, or increase your sample size to, let's say, 4,000 or 10,000 or something to get a better idea. But now we're going to run this bad number generator. And by looking at it, it looks good. I mean, we don't actually know what happens when math.random is called. And so that's why we can't actually be sure that it's going to be good or bad. But I've already told you, this isn't going to be so great. So I'm just going to change this method to bad, and we're going to see what happens. And I encourage you to experiment with your own different ways. There are lots of ways to get random numbers, including writing your own custom method instead of calling these math or secure random things. Alright, so now we have this new method. Now, as I told you, it only generates positive numbers. So the first numbers are all going to be 0. And obviously that's a bad thing, But let's see if there are any other flaws that it has. So when I copy all these numbers and paste it in Excel, we can see that obviously no negative numbers. So the first half of all the numbers is non-existent. And then we can see that the others sort of have high and low points. Now it's hard to tell. Maybe I can resize this thing. But there are, oops, there we go. There are little numbers. Each spot, if you can see at the bottom, seems to have some number, but the really probability is low that these numbers get hit. And then all of a sudden you have these tall lines which have huge probability of them getting hit. So you can see that the number generator, at least in my program, doesn't seem to be very accurate. And if we were to look at the actual numbers, we would see that this is true. You would see, you have numbers in thousands, 3,000, sort of fairly evenly distributed. And then we have these massive numbers. And you can also see a pattern emerging. We have numbers in the 1,000s, then 3,000s, then 1 again, and then a really big number. 1,000, 3,000, 1,000, big number. 1,000, 3,000, 1,000, big number. So you can see that isn't what we're wanting at all. That is a very poor distribution of our numbers. And so we want to avoid this method as much as possible and stick with a better method that's fairly evenly distributed. So I hope that this has made sense to you guys and will help you on your way to creating this amazing chess engine that we are building together. Thanks for watching. I hope you subscribe and enjoy Java.